for sin pi by 4, the value is 1 by root 2. So therefore, sin inverse 1 by root 2 is nothing but pi by 4. Whenever you have sin inverse of sin theta, then it can be written in the form of theta only when the range lies from minus pi by 2 to plus pi by 2. An inverse trigonometric function along with its function with the value of theta is true for all the principal value branches of the trigonometric function. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So we are in the chapter Inverse Trigonometric Function. In our previous session, we have studied how a trigonometric function can be invertible by restricting its domain as well as the range. In today's session, we'll be studying about the properties of all inverse trigonometric functions. So let's look at what is property number 1. So the property 1 says sin inverse of minus x is minus sin inverse x. So for the domain x belongs to minus 1, 1. We know the domain of all trigonometric function. I already told you, you will be having 1 mark question to write the principal value branch or the domain of any of the 6 trigonometric function. So this is the domain here given. Now here the inverse of a sine function is defined as sine inverse of minus x can be written as minus sine inverse x. Similarly, tan inverse of minus x can be written as minus tan inverse x. Cosecant inverse of minus x is minus cosecant inverse x. Cos inverse of minus x is pi minus cos inverse x. Secant inverse of minus x is pi minus secant inverse x. Cot inverse of minus x is pi minus cot inverse x for the domain x given to the interval here. So here, except for cos inverse and secant inverse function, all other trigonometric functions should be taken in the form of negative only. We know that cos function and secant function in any quadrant can be written in the form of pi minus cos inverse x, because we know that cos of minus x is nothing but cos x. Even though it is negative, we can make it as pi minus x so that it becomes positive. Thus for cos and secant function, it is pi minus cos inverse x and pi minus secant inverse x, and for all other trigonometric function, it is written in the form of minus sine inverse x, minus tan inverse x, minus cot inverse x, minus cosecant inverse x. Now let me take any one of the result to show that the value are equal. So I'll take the first one. So consider sine inverse of minus x is equal to minus sine inverse x for x belongs to minus 1, 1. Now let sine inverse of minus x is equal to y. So let me take minus x is equal to sine y. We have already know that whenever y is equal to sine inverse we have take, then x can be written as sine y. So that is why here I can take sine inverse of minus x is equal to minus y, means this implies minus x is equal to sine y. Change the sign here, so then it becomes x is equal to minus sine y. And minus sine y can be written as x is equal to sine of minus y. Now, if suppose x is equal to sine y, we can write y is equal to sine inverse x. Thus, I can write here sine inverse of x is equal to minus y. So, initially we have taken y as sine inverse of minus x here. So, here I can write sine inverse of x. I can change the sign to minus is equal to y here. So, y is nothing but sine inverse of minus x. So clearly say, therefore I can write sine inverse of minus x as minus sine inverse x. See here, sine inverse of minus x is minus sine inverse x. This is how we can prove. So here we'll take sine inverse of minus x as y. We'll change the function to the right hand side and we write minus x is equal to sine y. Then we change the sign towards right hand side. So x is equal to minus sine y. Minus of sine y can be written as sine of minus y. from the properties of trigonometric function. So I can write sine of minus y. Next I can take minus y as sine inverse x, change the sign again, then it becomes minus sine inverse x is equal to y. Y we have taken as sine inverse of minus x, replace it back, and hence we are proved. This is how we can prove the result, and for all the other trigonometric property, it is same as the result under the given domain. So remember this property because it helps while solving the problems. So next property, property 2 says sine inverse of 1 by x is equal to cosecant inverse x for x greater than or equal to 1 or x less than or equal to minus 1. Cos inverse of 1 by x is equal to secant inverse x. Tan inverse of 1 by x is equal to cot inverse x. We know that sine, cosecant are reciprocal to each other. Cos and secant are reciprocal to each other. Tan and cot are reciprocal to each other. So this is what the property under the inverse. We cannot write sine inverse x as 1 by cosecant inverse x. So this is not possible because since the domain is from the set of real numbers, that is only the real number values are taken, the value or the range of inverse trigonometric function is only the angles. We cannot write sine inverse x as 1 by cosecant inverse x. So this is how we define the property. Sine inverse of 1 by x is equal to cosecant inverse x. Cos inverse of 1 by x is secant inverse x. Tan inverse of 1 by x is equal to cot inverse x. So let us prove any one of the results here. So now how we can prove this? So let cosecant inverse x is equal to y. Then I can take x is equal to cosecant y. I also can take x is equal to 1 by sine y. If you take the reciprocal, I will get 1 by x is equal to sine y. If you change the function to left hand side, then it becomes sine inverse 1 by x is equal to y. What is y we have taken? It is cosecant inverse x. See here we have got sine inverse 1 by x is equal to cosecant inverse x. So this is why we have 1 by x and x here. So sine inverse of 1 by x can be written as cosecant inverse of x, and hence similarly we can write cos inverse 1 by x as secant inverse x, tan inverse 1 by x as cot inverse x. So this is how the inverse trigonometric function property number 2. Now using property number 1 and 2, we will solve few problems. So see here we have find the principal value of the following. We have to write what is the value for sine inverse 1 by root 2. So here we know that the domain of the sine function is from minus 1 to 1 and the range is from minus pi by 2 to plus pi by 2. So whatever the value you input in the form of a real number, the value you will get it in the angle form. So for what values of sine, it is 1 by root 2. So clearly we know that sine inverse of 1 by root 2 is nothing but pi by 4. Remember, for sine pi by 4, the value is 1 by root 2. So therefore, sine inverse 1 by root 2 is nothing but pi by 4. Next one, cot inverse minus 1 by root 3. Here we have cot inverse of minus x. So this should be written in the form of minus cot inverse x. So therefore, this can be written in the form of minus cot inverse 1 by root 3. So for what values of cot, it is 1 by root 3. So therefore, it is pi by 3, hence it is minus pi by 3. Cot pi by 3 is 1 by root 3. So therefore, cot inverse of 1 by root 3 is pi by 3. Cot pi by 3 is 1 by root 3. So therefore, pi by 3 is nothing but cot inverse of 1 by root 3. So therefore, for cot inverse of 1 by root 3, we get pi by 3. Outside we have negative, so hence it is minus pi by 3. If you want to remove minus here, you can take it in the form of pi minus pi by 3 also. Next one, cosecant inverse 2. We know that cosecant pi by 6 is equal to 2. So therefore, we can write cosecant inverse of 2 as pi by 6. So therefore, the value or the principal value for this function is pi by 6. Or we can take cosecant inverse of 2 as sine inverse 1 by 2 from the property 2. So for what values of sine, the value was half for pi by 6. Hence, pi by 6. Next one we have tan inverse minus root 3. Tan inverse of minus x can be written as minus tan inverse x. So therefore, it is minus tan inverse root 3. So for what values? It is root 3. So it is pi by 3. Next we have cos inverse of minus half. So cos inverse of minus half means we should take it in the form of pi minus cos inverse half. So for what values of angle you will get half in cos function? So that is for pi by 3. So therefore it is pi minus pi by 3, which becomes 2 pi by 3. This is the principal value for cos inverse of minus half. So next one, find the values of the following: tan inverse of 1, cos inverse of minus half, sine inverse of minus half. So tan inverse of 1 can be written as same. So tan inverse of minus 1. Here cos inverse of minus half means we should write this in the form of pi minus cos inverse half. And here this becomes minus sine inverse half using property 1. Now tan inverse of 1 means it is pi by 4 because tan 45 is 1. So therefore tan inverse of 1 is pi by 4. Similarly, we have pi here. Cos inverse half is nothing but for what values of cos function it is half? For pi by 3. So therefore cos inverse half is pi by 3 and it is minus pi by 6. So take the LCM of these functions. So we have 12 here. So 4 3s are, and here 12 pi minus 3 4s are minus, and here 6 2s are 2 pi. So 15 pi minus 6 pi, we get it as 9 pi by 12. When you cancel it, it is 3 pi by 4. So this is the value of the given inverse equation. Next one, cos inverse half plus 2 sin inverse half. So cos inverse half is nothing but pi by 3 plus 2 sin inverse half is nothing but pi by 6. Cancels, we will get pi by 3 plus pi by 3. We get it as 2 pi by 3. Next question, tan inverse root 3 minus secant inverse of minus 2. Secant inverse of minus x must be written in the form of pi minus secant inverses. Only for cos and secant, you can take it in the form of pi minus cos inverse and pi minus secant inverse. So therefore this is tan inverse root 3 minus pi minus secant inverse of 2. So here it is tan inverse root 3 is nothing but pi by 3 minus pi minus this is pi by 3. So pi by 3 minus 2 pi by 3, which is equal to minus pi by 3. The denominator is same, so pi minus 2 pi is minus pi. So hence the value is minus pi by 3. So next question, property number 3. Sine inverse of sine theta is theta. Here theta represents the angles where theta lies between minus pi by 2 to plus pi by 2. So this is in the range. So theta lies in the range here. So the range of sine inverse function is from minus pi by 2 to plus pi by 2. Whenever you have sine inverse of sine theta, then it can be written in the form of theta only when the range lies from minus pi by 2 to plus pi by 2. That is, whenever the angle lies from minus 90 to plus 90, we can write sine inverse of sine theta as theta. Similarly, we can write cos inverse of cos theta as theta whenever angle lies between 0 to pi. Next, tan inverse of tan theta is equal to theta whenever the angle lies between minus pi by 2 to plus pi by 2 strictly. So here, this is possible only for the principal value branches. Next, cot inverse of cot theta can be written as theta for the principal value branch 0 to pi. Secant inverse of secant theta is possible for all the values from 0 to pi except theta cannot be equal to pi by 2. Next, cosecant inverse of cosecant theta can be written as minus pi by 2 to theta to plus pi by 2 except for the angle theta is equal to 0. An inverse trigonometric function along with its function with the value of theta is true for all the principal value branches of the trigonometric function. Now let's see the problems. Find the values of the following. The first one is sine inverse of sine 2 pi by 3. We have to find the value. We know that sine inverse of sine theta is equal to theta when theta lies between pi by 2 to minus pi by 2. So here theta does not lie between minus pi by 2 to pi by 2. So let's evaluate this. So sine inverse of sine 2 pi by 3 can be written as sine pi minus pi by 3. Pi minus pi by 3 means 2 pi by 3, which lies in the second quadrant, and in the second quadrant sine is positive. So I can write this as sine inverse of sine pi by 3. We know that sine pi minus theta is sine theta because it lies in the second quadrant and it is positive. So therefore the value is pi by 3 now, because pi by 3 lies between minus pi by 2 to plus pi by 2. Next one, tan inverse of tan 3 pi by 4. So here also we can write tan inverse of tan pi minus pi by 4. 3 pi by 4 can be converted into pi minus pi by 4. Why? Because the property tan inverse of tan theta is theta only for the values when it lies between minus pi by 2 to plus pi by 2. So therefore it is greater than pi by 2. Hence we have to convert this in the form of tan pi minus theta. And tan pi minus theta is tan theta. But pi minus theta means it lies in second quadrant. This is pi. So pi minus theta means it lies in the second quadrant. In the second quadrant, tan is negative. So we have to take this in the form of minus tan theta. So therefore it is tan inverse of minus tan pi by 4. And we know that minus tan theta can be written as tan of minus theta using the properties of trigonometric function. So therefore I can write this as tan inverse of tan of minus pi by 4. Now minus pi by 4 lies between these interval. Hence I can use the property tan inverse of tan theta as theta. So therefore the value is minus pi by 4. Next question. Sine inverse of sine 3 pi by 5. We can also solve this using the degree values. You can convert this radian into degree. Sine inverse of sine, this is 108 degree. When you solve 3 pi by 5, you will get the value as 108 degree. But 108 does not lie in the principal value branch. So therefore I can write this as sine inverse of sine 180 minus 72. And we know that sine 180 minus theta can be written as sine theta. So therefore it is sine inverse of sine 72 degree. So hence now 72 degree lies between minus pi by 2 to plus pi by 2. Hence we can write sine inverse of sine theta as theta. So therefore the value is 72 degree. So we can keep the solution in the form of radians also, or we can convert it into degree. Then we have write the solution in the degree also. So remember the property 1, property 2, property 3 to solve the problems. We'll continue a few more properties in our next session. Until then, keep watching, keep learning, keep exploring. Thank you.